Hello student, I am welcoming all of you on this Drishti online platform, and we are discussing about the 100 most important topics of geography for the 2026 prelims. And in the first episodes I have given some questions. So first of all, I am going to what I said that answer those questions, and thereafter today's the some important topics we will see that the last episode we have seen that P, S and L seismic waves. Shadow zone, we have seen that chemical layers of the Earth's interior, mechanical layers of the Earth's interior, earthquake swarm in California and Iceland we have seen. Now let us see some of the important, I say that the questions that we have seen in the last, and just I'm going to give the answer of it. So first of all, that we have seen, consider the following statement regarding seismic waves. The P waves are longitudinal waves. Yes, the P waves are longitudinal waves. It is correct. Longitudinal wave and can travel through the solid and liquid and gaseous medium. Yeah, this is the correct statement. Second, S waves are the transverse waves and cannot travel through the liquids. So S wave, it is a correct one. It cannot travel through the, what I said that it cannot, you can be able to say like, it is a correct one. And here the S waves, transverse wave, cannot travel through the liquid medium, and this is, and it is what I can say that it is also the correct statement, because it is in a shear wave. S wave is in a shear wave, and when it is in a moving perpendicular direction of the wave, so it cannot go through the liquid. So because of that, we are able to understand that outer core is in a liquid. So here it is in a S waves are transverse waves and cannot travel through the liquid. It is correct one. L waves travel through the interior of the earth faster. So first of all, this L wave, that is known as a love wave, it is moving on the surface of the earth, not earth's interior. So that's why we can say that it is in a wrong one, and we can say that only 1 and 2 is correct of this question. And thereafter we have to see the next question. Consider the following statement about shadow zone of seismic waves. And again, I am telling you, all these questions are very much important for the prelims 2026. And here that shadow zone of seismic waves, regarding that, the shadow zone, and then it refers to the areas on the earth where no seismic waves are recorded, and it is in a what, correct one. Here no seismic waves are recorded. It is correct one. S waves create a shadow zone because they cannot travel through the liquid outer core. So S wave create a shadow zone because it cannot travel through the liquid outer core. Yes, this is also correct one. And P waves do not form any shadow zone. So P waves form a shadow zone, therefore this statement is wrong. Here it is saying that P waves do not form any shadow zone. So only 1 and 2 is correct, and this option is correct one. And then next question that it is we have to see like consider the following statement regarding chemical layers of the earth. Chemical layers, all of you know that it is in a you know that crust, it is Sial, and then mantle, it is in a Sima, and there is in a Nife, it is in a core. They are the three major division on the basis of chemical layers. The earth is chemically divided into crust, mantle, inner core and outer core. No, it is only core. Inner core and outer core, it is on the basis of what you can be able to say mechanical layers. It is so this is a wrong statement. This is wrong, because only three: crust, mantle and core. The mantle is mainly composed of silicate minerals rich in magnesium and iron. Yes, it is in a magnesium. In the mantle, if you go, silica will keep on reducing, but at the same time, along with the magnesium, some silicate will be there. Along with the iron, some silicate, means Sima it is known as. So this statement is, you can say that correct. The core is primarily composed of nickel, ferrous and aluminum. Yes, core is made up of nickel and ferrous, but not aluminum. So that only second statement is correct. So here 2 only, it is okay. Now moving toward the next question here, consider the following statement regarding mechanical layers of the earth. The lithosphere is rigid, and the mechanical layers means is talking about that behavior. It is rigidity, soft, different kind of aspects of it. So lithosphere is rigid, and it includes the crust, the uppermost mantle. So lithosphere is made up of upper crust and crust part, and then upper solid mantle. So here it is talking about the same. It is in rigid, and it includes the crust and an uppermost mantle. So you know that mechanical layers, if I am talking about lithosphere, asthenosphere, mesosphere, and there is an outer core and inner core. These are what we can be able to say the division of mechanical layer. The asthenosphere is partially molten and allows tectonic plates to move on it. Yes, that our continental and oceanic plates are moving on it. So that's why this statement is also correct. And the mesosphere corresponds roughly to the lower mantle. Yes, the lithosphere, the mesosphere, after the upper solid mantle, asthenosphere and all, there is whatever the left mesosphere, lower mesosphere is part of what I said, that it is in a the mesosphere correspond to the lower mantle. This is also correct. And if you want to understand these questions and how do their answers are there, so please watch the first episode of this. I said 100 topics, the 100 most important topics of the prelims 2026. First episode, you will see all the basic idea why do these answers are there, so you can be able to understand. So here it is, all the three are correct, so we can be able to say 1, 2 and 3. Thereafter, we have to see that questions related to earthquake swarm. Then earthquake swarm. Consider the following statement related to earthquake swarm. Earthquake swarms refers to a sequence of many earthquakes. Yes, there is a sequence of many earthquakes occurring in a small area within a short period of time without a single dominant main shock. There is never a major shock. In this one earthquake swarm, there is never a major shock will be there. So this statement is a correct one. Earthquake swarms are commonly associated with the volcanic activity and geothermal regions. Yes, volcanic activity, there will be you can say that divergent boundary through the volcanoes are coming, transform boundary along the California. That is such kind of it. So when the divergent is taking place, some geothermal means you can say that geo means earth, and thermal means hot, and water it is coming, geothermal vent along the divergent boundary. So in the Iceland, this kind of activity you can be able to say, so geothermal regions and volcanic activity, both are what I said that correct. It is in earthquake swarms. And then earthquake swarms always result in a major destructive earthquake. It is not a major, it is never a major. It is what I said, that is small equal magnitude on it. I said that a small earthquake it will be there, a small earthquake. So there is never a major earthquake or destructive earthquake. So only 1 and 2 is correct of this statement. This 1 and 2. So the correct option is this one, A. And thereafter we are going to see that earthquake swarms in California. So California, it is in the transform boundary related to that. So earthquake swarms in California are often associated with the movement of fluids in geothermal regions. Yes, below that some fluids are coming into that, and then helping in the plate to what I said, that making small earthquake slightly disturbing. So it is in a correct one statement. And then earthquake swarms in California always precede a major earthquake. Never, before and after, there will be never a major earthquake. So this statement is wrong. And such swarms can occur along the transform plate boundaries such as San Andreas Fault. If it is talking about earthquake swarms in California, it is along the California state of USA. There is San Andreas Fault is there. So this statement is also correct. So we can be able to say that 1 and 3 is correct. So we have been able to see these questions, that how it is there, and we can be able to say related to earthquake swarms in the Iceland. So with reference to the earthquake swarms in Iceland, consider the following statement. Earthquake swarms in the Iceland occur only due to transform fault activity. It is not transform. The California is transform, here is a divergent. So it is in a not transform. Earthquake swarms in Iceland are often associated with the magma movement beneath the volcanic system. Yes, magmas are coming, and slowly it is coming, and therefore there will be a small earthquakes are there at regular interval and equal magnitude. Iceland is located along the mid-Atlantic ridge where the North American plates and the Eurasian plates are moving apart. Yes, it is a correct statement. So we can be able to say that 2 and 3 is correct. So please, again I say that the statement B option is correct, 2 and 3. And if you are able to understand these questions, then it's okay. Otherwise, if you want to again understand this question answers, so go and see the last episode. Now we are going to start with this second episode for the that 100 most important topic for geography, in which we are going to cover about the plate tectonics, divergent boundary, convergent boundary, formation of the Himalayas, formation of the Andes, formation of the island arcs or volcanic island arcs. Here, that first one we are going to see that there is a convectional current of magma, which is we can be able to say that there is a convectional current of magma from the below. You can be able to say that the plates magma is coming, and this magma keeps on moving like that, and it is putting in a friction on the plates. Because of that, you can say that the plates are diverging, and such two divergence again at some other place if the divergence is occurring. So that one plate, it is in a divergence is here, another is in a divergence. So because of two divergence, one convergence will take place. So because the plate tectonic, it is happening majorly, the major force responsible for that, it is what convectional current of magma. And here that is in a plate tectonics. In the plate tectonics, what is the major thing it is there? So major thing it is there that plates are, I say that moving away, diverging, and some reason that converging. So at the part where it is in a diverging, the new ocean floor forms constructive margin. At the part where it is in a converging, the plates, one denser plate will subduct below. So here we can be able to say that somewhere what construction is taking place when the divergence, new ocean floor always form constructive margin, and at the convergence, one what we can say that one old oceanic floor is subducting and destroying, so destructive. So plate tectonics, plate means plate movement is happening, and then tectonics we can be able to say that it is in somewhere destruction and somewhere construction of the plate is taking place. So here you can say that the plate tectonics is the theory that explains the movement of large, you can say the large rigid plates of the Earth's lithosphere over the semi-molten asthenosphere. So here we can be able to say that these zigzag lines which are moving here, it is in a divergent boundary, it is in a kind of divergent boundary, and here it is also kind of divergence. Here Pacific plate is moving this side, Nazca plate is moving this side. So this is a divergent part, we can say. Here it is also divergent. Because of that, South American plate which is moving westward and Nazca plate is moving eastward. So when it is moving, so there is a convergence is going on, and due to the convergence, one Nazca oceanic plate is subducting below, and there is a formation of what Andes, you can be able to say the plate tectonics, and these plates are floating over semi-molten asthenosphere. Below, these all continental and oceanic plates are floating over semi-molten again asthenosphere. Like I say, there is ships are moving like that, what ships are moving over the ocean. Similarly, our continental and oceanic plates are, that is the lithosphere, we can say that lithosphere, rigid lithosphere. Plates means lithosphere, and when they are moving, somewhere converging, somewhere diverging. So here, and then lithosphere is broken into major and what I said, that some minor tectonic plates. So major, you can say that North American, South American, African, Eurasian, India and Australia together moving northward, Antarctica, some major plates are there. A part of it we have seen there is a Nazca, Cocos, Juan de Fuca, Caribbean. Such there are several what minor plates are also there. So there is in this one that some major and minor tectonic plate. These plates move due to the mental convection, slab pull and ridge push. These are the three reasons why do the plates are moving. Major force is what? Convectional current of magma, as we have seen already. The major force of what the plate to move, it is in a convectional current of magma. When the magma moves up, it is putting a frictional drag on the Earth's plate, and the Earth's plate started breaking and diverging. So here we can say that the three forces, convectional current, slab pull and ridge push. Here we can be able to say that three forces are there: mental convection, slab pull and ridge pushes are there. Is it okay? So here we can be able to say that okay, the convectional current of magma, this is the first important we can be able to say that force is, then first important force is what? Convectional current of magma, and which is we can be able to say putting a frictional, or say it is moving away. But at the same time we can say that this measure, this is the uplifted portion. This uplifted portion is known as a ridge, and any ridge it is uplifted having filling in a more gravity, it is trying to under the gravity pushing it down. So the ridge is also pushing it down under the gravity. The plates help in what movement, and then there is a what ridge push is also responsible for the plate movement. And when it is going, when the denser oceanic plate is converging somewhere, so when it is going inside, then it is moving into the semi-molten asthenosphere, and then it is considered as what under the gravity. It is this oceanic floor having more denser, and then asthenosphere is the less denser. So like if you have seen in the paint, if you are putting some sticks and rod anything, so in the paint box it will start slowly moving. In the same way, you can say that our ocean floor at the subduction zone, it is what I said that having more density, easily what pulling down itself under the gravity inside the what semi-molten asthenosphere. It is known as a slab pull. So when it is pulling it down, that helps in the plate movement. So three forces are responsible for the plate movement: convectional current of magma, and ridge push and slab pull. And there is an you can say slab pull. So here let us see the question based on whatever we have seen, and you have to answer, and you have to comment that answer in the what comment box. So the first question we are going to see, with reference to the plate tectonics, consider the following. The first one, it explains the movement of large rigid plates forming the Earth's lithosphere. So lithosphere means plate itself. So you have to answer whether it is correct or wrong. Another, the movement of these plates occur over the semi-molten layer called asthenosphere. You have to see that whether this statement is right or wrong. Another point that we are watching, according to the plate tectonics, convection of magma, slab pull force is only responsible. It is talking about only responsible for the plate movement. No, we have seen, but sorry, we have to see that whether it is in which one the forces are there. So okay, accordingly you have to answer this question. Is it okay? So and in this question answer will be given in the next episode, so please go and check it out, or in the next episode also. So here the next part we are going to see, it is about the divergence. You know that who is causing divergence? Again, convectional current of magma is responsible for the water divergence. So let us see about what divergence of the plates. Here you can be able to see in this region also, the plates are keep on convectional current of magma, the plates are diverging, and in the middle portion there is always one small basaltic layer of magma is forming, new ocean layer, always one layer is forming, and they keep on diverging, they keep on, again I say that, diverging, and new ocean floor is, you can be able to say, forming. The same way, suppose we can say that we can say like again this way, earlier North America, South America and Africa were together, and thereafter they started moving away, and in between mid-Atlantic ocean is keep on forming, and the middle part of this ocean, there is due to the hotness over there, this section is uplifted, and it is looking like an uplifted chain of mountain range in the middle of ocean. It is known as a mid-oceanic ridge. And here always new oceanic crust is forming. So along the divergent, when the two divergent plate boundaries, when two tectonic plates move away from each other, it is known as the divergence. The mantle convection brings magma upwards. When it is coming away, so when the always along the divergent, when the plates move away, the gap created in which basaltic magma comes, this in convectional current of magma is in a basaltic magma. Is it okay? And that is putting in a frictional drag on the Earth's plate, and Earth's plate keep on diverging. When keep on diverging, breaking in the middle, gap create. In this gap, there is basaltic magma comes, and formation of new ocean floor of basaltic magma. So here that mantle convection brings magma upward. Magma rises through the cracks. When the plates keep on moving away, the rises through the cracks, it cools and forms a new crust. Therefore, this divergent boundary is also known as a constructive margin, because formation of new ocean floor. And then plates slowly move apart. And this is also known as this process is also called sea floor spreading, because it helps in the making the plate to move away. Sea floor, formation of sea floor, and keeps on moving away, spreading. So the landform produced, here it is in a mid-oceanic ridge. Yes, in the middle part because of the hotness, this has been uplifted and it is looking like a chain of mountain range, mid-Atlantic ridge, mid-oceanic ridge, everywhere in the world, Pacific, Atlantic, Indian, where the plates are diverging in that region, in the middle section it will be uplifted chain of mountain ridge, and that is known as a mid-oceanic ridge, and the longest mid-oceanic ridge in the Atlantic Ocean known as a mid-Atlantic ridge. So here we have seen about this one, and here some examples of the divergence. We can say that mid-Atlantic ridge here, this is your what earlier this North American and Eurasian plate were together, thereafter keep on diverging away. This South American and African plates were together, thereafter keep on diverging. In the middle ocean there is an Atlantic Ocean, keep on new ocean crust keep on forming, and here in the middle it is known as an S shape. This is what S shape mid-Atlantic ridge. Here mid-Atlantic ridge, and it is in a mid-oceanic ridge. All yellow color lines, whatever you have seen, all yellow color line is in a what divergent boundary, and there will be a mid-oceanic ridge. East African Rift Valley, along the eastern part of Africa, there is also divergence is going on, and is in a part of what you can say divergence. So we have seen this one, and here now that question based on that consider the following statements regarding divergent plate boundaries. Divergent plate boundaries, if I say first statement, involve movement of plates away from each other. So you have to see whether it is a correct or wrong. And the new crust is created at the divergent boundary. Yes, again you have to try to give this answer. And divergent boundaries are commonly associated with the deep ocean trenches. Yes, you have to see whether this statement is correct or wrong. So accordingly you have to answer this question in the next episode again. But just if you are getting any problem, again watch the videos, it will help you to answer this one. Is it okay? Next part I said volcanic eruption at Iceland. We have seen volcanic eruption at Iceland. Iceland is along the divergent boundary, you know that, and it is related to the current affairs. Here we have seen that there is Grindavik is a fishing town located at the Rigsnes Peninsula, Iceland. Rigsnes, you know that the capital of Iceland is Reykjavik. Capital of Iceland is Reykjavik, and there is some portion of this Iceland is known as the Rigsnes, and in this one volcanic eruption, divergent plate boundary, yes or not, and when the plate will diverge, magma will come. So and the area lies near the mid-Atlantic ridge. So this is the Iceland is along the mid-Atlantic ridge, where the North American plates and Eurasian plates are moving apart. Is it okay? And because of this divergent plate boundary, magma easily rises to the surface and causing frequent volcanic eruptions and earthquake swarms. So along there will be lots of earthquakes. Slowly some earthquakes comes in this region. And what we can say that in the recent volcanic activity of 2023 and 2024, intense earthquake swarms occurred near, yes, Grindavik. So must remember this Grindavik, indicating magma intrusion beneath the surface. So from below the earth's surface, magma is coming up into it is intrusion. Lava flows is sprayed across the Rigsnes. So when it is coming, and when the magma comes on the earth's surface known as lava, and it is spreading all around, it is in a very less viscous. When anything less viscous like a liquid will keep on spreading, and peninsula through it is keep on spreading across the Rigsnes Peninsula through the fissure eruption. You know that divergent boundary is always known as a fissure eruption, threatening infrastructure and forcing evacuation of the residents. Those what I said that the magma is keep on moving, and then all the infrastructure loss damages, and then people has to evacuate that place. Another the question based on that. So consider the following statement regarding the divergent plate boundary. So we can be able to say that divergent boundaries involve movement of plates away from each other. New crust is created at divergent boundaries, and then divergent boundaries are commonly associated with the deep ocean. Okay, we have seen this question earlier. So now the convergence, we have to see some question based on what I say that convergence. So and then topic associated with the convergence, you know that when the convergence was taking place, three types of convergence: continental, oceanic, and oceanic continental. Here it is, we are watching, it is an oceanic continental, here it is an oceanic, and here continental convergence. Three convergences are there, and a convergent boundary occurs when the two what the tectonic plates move towards each other. That's very easy. One plate may subduct beneath the another, or both may collide. So when the one plate is in a always in case of one ocean will be there, when there will be one ocean plate will be there, must be subduction. Means ocean, continental ocean is more denser and it is made up of iron, magnesium, more denser. So it will when they are converging, so because of more denser, putting more pressure on the astronosphere, so it will subduct below. Is it okay? It will subduct below. In the case of ocean convergence, one ocean, another ocean, the one ocean which is more of more denser, it will keep on converging and subduct below. But when the two continental plates are coming towards each other, so both are putting same pressure over the astronosphere, because these plates are plate tectonics are moving over the astronosphere semi-molten, and the two continental plates will be there. So they will put in a what same pressure when they will come towards each other. So the nothing, they have a maintained same level, therefore they will collide. Continental collide, like Himalaya has been formed here. And there are the three types of what we have seen. Convergence are there, and with reference to the convergent plate boundary, consider the following statement. Convergent boundaries occur where two tectonic plates move towards each other. Where two tectonic plates, what we can say, that move towards each other. This is the one question we have seen, that whether you have it is in a correct statement or wrong, we have to answer it. Convergent boundaries are associated only with volcanic activity, not with earthquake. So that we have to say. And whether it is there or not, again I am saying you that there will be, when the plate tectonics will be there, and when it is going on, please again these things related to earthquake and volcanic activity, when we will move ahead, you can be able to see those answers can come also. And after that, subduction commonly occurs when the denser oceanic plate moves beneath the continental plate. So what I said, that commonly occurs when a denser oceanic plate, yes, and a subduct oceanic plate moves beneath the continental plate. So this statement is right or wrong, you have to answer it accordingly. Another, that ocean continental, so we have to see separately, and for every ocean continental I will give some ideas when the basic fundamental concept. Another one will go for oceanic, and then continental. Understood? And Himalaya has been formed by the what continental convergence. So here we can be able to see, like I said, that when the one oceanic plate is converging and then continental, what you can say, that the denser oceanic plate subduct below less denser continental plate. So in this region here you can be able to say that due to the friction, heat generate and magma forms, and it is causing volcanic eruption. And also you can say that again it is subducting below, there is some kind of sediments will be deposited, river sediments, and these sediments and some accretionary waste sediment will start what compressing. When the what we can be able to say, suppose one plate is going like that, another plate is over there, ocean, here you can say that this is an ocean, then there will be some amount of what you can say, there is a river deposited sediment, and one oceanic plate is going down here. So this sediments under the what compressional force buckled into the fold mountain of what I said, that like Andes has been formed also same way. So here it is in a fold mountain in the coastal area. Again you can watch it out, that when the Nazca plate, you know that if I am talking about, yes, denser oceanic Nazca plate, here denser oceanic Nazca plate, it is going down, and here it is what you can say, this is in a South American continental plate, and here it is in a Nazca oceanic plate, it is going down, and here you can say like in this region ocean is there, and here you can be able to see like under in this region the river will from this side, river has deposited lots of sediment. Under compressional force it will convert into, under compressional force it will convert into, when it is going down, then under the compressional force there is a formation of what you can say, there is a fold mountain of what Andes has been formed, and this mountain has been, and this is the deepest part of the ocean, there will be what trench will also form. This is in a trench, and this fold mountain, as well as when it is going down, I have shown you in this picture that there is in this picture there is a formation of magma is there, and this magma is causing volcanic eruption also. And when it is going down, then there will be also earthquake along the divergent also, and along the convergent, always anywhere the plates are moving, magma and what I said, that volcanic eruption, and then what we can say, that earthquake will keep on coming. So here we have seen Andes mountain has been formed by the Nazca plate, and then this is what South American continental plates converges. Is it okay? Ocean continental convergence. Here, with reference to the Andes mountain, consider the following. They were formed due to the subduction of Nazca plate beneath the South American plate. It is okay, whether we have to see whether it is in a right or wrong. They are associated with the volcanic activity. Yes, again you have to say whether it is right or wrong. They are an example of ocean continental plate diverges. So please give the comments which answer is correct regarding that. Yes, so in the next episode we will answer it. And another one, we are going to see continental collision. So if I am talking about continental, this is in a continental plate, and it is also a continental plate. The two continental plates are coming towards each other, and we can be able to say like the deposited sediments in between them, the river from both the side deposited the sediments. So due to the movement, you can say that these sediments will be able to buckle into what? Fold mountain. When these plates will come, here you can say that when the two continental plates will come, the deposited sediment in between them, it will fold into what? Fold mountain under the compressional force of continental convergence. And here you can be able to say like here the deposited sediment in between the two continental plates are, you can be able to say that folding and converting into the fold mountain like Himalayas. What we can be able to say the same way. And then Himalayas here, that continental collision and the formation of Himalayas. The Himalayas formed due to the collision, and the collision means when the two same continental plates are there, same density, they are same putting pressure on the ionosphere. So when they will come towards each other, they will collide. And when they will collide, we can be able to say that collide means same, no subduction. When the two continental plates are coming towards each other, no subduction, only collision. So process of formation, the Indian plate moved northward. Here you can say that it's like suppose Indian continental plate is moving northward. I will show you here. Here it is an Indian Gondwana continental plate is moving northward, and there is what Eurasian continental plates are there. So the two continental plates, when they will collide, what I said that the Indian plates move northward at high speed and collided with the Eurasian plate around 50 minutes ago. The ocean between them is called Tethys Sea. So here you can say there is a Tethys Sea in between them, and here that sediment of the Tethys Sea were compressed and folded into the fold mountain, and this create the Himalayan mountains. So here let us see how it is happening. Suppose this is an Indian Gondwana continental plate is coming on, and there is an Eurasian continental. So this is in a Tethys Sea, and below it is in a in this region the river from both the side deposited the sediments. This is a deposited sediment, and this sediment is, I said, that buckled into the fold mountain of first of all Greater Himalaya. Again there is a deep is existing. This is known as a four dip in front of the Greater Himalaya. In the front of the Greater Himalaya, again a deep is existing. This is known as a four dip, and this deposited sediment, again the river from both the side deposited sediment under the continental convergence compressional force, it is buckled into what? Middle Himalayas. Again in front of the Middle Himalayas, what you can say that a four dip is existing, and in this four dip, four means in front and deep means deep. So in the front of what? In the four dip of Middle Himalayas, again the river from both the side deposited the sediment, and these sediments, what I said that it has been buckled under the compressional force. This sediment under the continental convergence compressional force buckled into what? Shivalik range. And again after that, in the front of this Shivalik range, that again a four dip was existing, and it has filled up with the sediment from both the sides and become an Indo-Gangetic plain, including Punjab, Haryana, Delhi, UP, Bihar, West Bengal and Assam. So this is an alluvial soil region also. So this way here we have been able to say there is in a greater Himalaya, and this region you can say that Indo-Gangetic plain. This is in a greater Himalaya. This is in a middle Himalaya, and this is your Shivalik range. So we have been able to see that how do the Himalayas. So now consider the following statement regarding this topic. The Himalayas are formed due to collision between Indian plate and Eurasian plate. Yes, you have to answer whether it is a right or wrong statement. The formation of the Himalayas involved in volcanic activities. So you have to say that whether did I discuss about the volcanic activity or not. So you have to see the Himalayas are geologically young fold mountain. Yes, yes, any convergent in the presently it is happening. All are what I said that Andes and all whatever I am talking about, all are young fold mountain. So this statement already I have given the answer of it, because I did mention in the when I was explaining about it. So here now we are going to see oceanic convergence. In the oceanic convergence, formation of island arcs are going to take place. This topic we have to see, and you can be able to say that in this region, when the one oceanic plate is subducting below over the another oceanic plate, due to the friction there is a formation of heat, magma forms, and this magma comes up and they keep on coming slowly and slowly. Those islands come above the sea surface, magma comes, and slowly it they started forming on a small feature on the ocean floor. Slowly and slowly it comes above the sea surface, become volcanic island, and it is always in the arc shape, therefore it is known as a volcanic island arc. Ocean convergence. So here we can be able to say that here in this region, like one Pacific oceanic plate, which is I said that going below, and here it is the Eurasian oceanic plate. So when it is going down, so there is a friction is there, and then magma forms and magma comes above, and it is in a what you can say that there is in a group of what you can say that islands are there. Yes, Japan island has been formed. It is in the arc shape, volcanic island arc. And in front of it, when the plates are what you can say that in this front, the deepest part of the ocean trench exists. In the ocean continental and in the ocean, in these two times you can be able to say the trench is existing, and there is a volcanic eruption is there also. You can say there is a volcanic eruption, volcanic island arc, and earthquake, and also there will be a trench will form. So these are the things important for the ocean convergence or oceanic convergence. So when the two oceanic plates, what I said that here it is we have to say converges. One plate subducts beneath the other. The process, one denser oceanic plate sinks into the mantle, another denser oceanic plate it is going below, and then subduction generates magma. Subduction, because of the subduction there is a heat generate and creates magma, and this magma rises and forms volcanic islands, and a curved chain of island forms. It is known as an island arc. An example: Japan islands, Aleutian islands, Philippines islands. Several islands in this Japan island you can be able to say there is in the Pacific western part you can say Aleutian, Kuril, Philippines, New Zealand. All these are I say that it is in a kind of volcanic island arc, and parallel to them there is trenches are there. And earthquake, all these things will happen. Even tsunami also occur, but here I am just talking about consider the following statements regarding island arcs. The island arcs are formed due to the oceanic convergent plate boundaries. You have to see whether it is right or wrong. They consist of chains of volcanic island. You have to say yes or not. They are commonly associated with the deep oceanic trench. Yes, they have a trench or not. The deep oceanic trenches are the deepest part of the ocean. Is it okay? So this question that we have to see, and I will ask all of you that please it is give your answer. Again watch the video and see what could be the answer of it, and then comment, and I will answer all the answers of it in the next episode. And in the next episode we will answer all the questions. So we will see another important topics in this one. So till then,
for more informative content, like, share and subscribe, and do not forget to press the bell icon to get the notifications.